And we're live.
You're live. Good night, people. You have. I'm very nervous because it's my first live in English, so I'm so sorry. And now you have the honor to bring Mads Torgersen to our channel in Conhecer. Thank very much, Mads Torgersen, to be here in our channel, to be here to talk to our community Brazil. Thank very much.
Well, thanks for the opportunity to be here. I am really happy that this was sort of a happy coincidence. Raphael asked me a few questions for his master's thesis, and which is about C# and pattern matching, and of course I'm passionate about those things. And Raphael asked me if I, since we were talking, if I couldn't drop by this user group, and of course I'm very happy to, and I'm very eager to hear your questions, talk to you about the things you're passionate about in C#. And I'm not going to get started just yet because Raphael told me that people usually keep trickling in until about 9:15. So we can sort of just chat until then, and then we can get started on something that's a little more like a talk.
Yeah. I will start to say in Portuguese some words. Pessoal, cara, se vocês quiserem, começa a fazer pergunta, vamos interagir aqui com o Mads, tá? A ideia aqui é a gente fazer uma live extremamente interativa, tá? Vamos interagir com ele. Cara, é uma oportunidade muito boa aqui para a gente começar, cara, de uma pessoa tão importante quanto o Mads aqui na Microsoft. Assim, só para curiosidade, eu estava fazendo uma questão de mestrado e mandei um e-mail para o Mads, né, falando sobre, como que você fala sobre o pattern matching, ele vai ser, ele consegue melhorar a questão da legibilidade do código. Cara, eu assim, mandei para ele e falei, cara, esse cara não vai nem me responder. E, cara, o cara me respondeu de noite. Então, e ele se propôs para fazer uma live aqui com a gente, para trazer essas funcionalidades e falar sobre isso. Cara, então, cara, é uma oportunidade muito boa, uma oportunidade única para a gente, pessoal. Única mesmo. Matt, I want to tell you about the people, about that I send the email about the C# language, and the curiosity that I think you'll not answer to me. I think it's a very busy guy. It's not answer to me. I have a lot of response. Why you answer to me? But you answer to me, and now you are here with me. I'm very, very pleased, very honored to be here. E pessoal, Matt, there is a question about José Silva. Which feature? Display. If you want to see.
Which feature from functional languages like F# do you want to bring to C#? That's a great question because, and it comes with great insight because as you've probably noticed, Jose, we've already brought a lot of functional features into C#. We can maybe look at some of the recent ones that we added in C#9 and a little bit in C#10, which is not out yet. So I'm happy to go to Visual Studio and play at some point and look at that. But it's a good question. What's still there in functional languages that we haven't already stolen, so to speak, into C#, what we haven't already copied? In some ways, I don't know that there's very much left that we will take, but I might be surprised. I think we've taken big things like pattern matching. We've sort of taken the concept of pattern matching, put it in C#, and we make it better every release, almost every release. The improvements for pattern matching in C#10 didn't make it, so they will be C#11. But other than that, I think the next thing, but we will keep, the way we keep improving things is, of course, we keep looking at functional languages. For instance, we're now looking at list patterns as the next kind of patterns that we would support in C#. That'll probably be C#11. So we keep like taking little things. There's a point where functional features become very hard to introduce into an object-oriented language. Functional programming languages often have very strong type inference because they have very weak subtyping, which is the thing that makes object-oriented programming run, right? You have this hierarchy of classes, and you can assign them to each other. And because of that, it's harder to make type inference as good in an object-oriented language as it is in a functional language. And I don't think we'll ever get to a point where types are as implicit in C# as they can be in a nicely written F# program. So that's sort of a negative answer. That's a place we probably won't be able to fully go, even though we certainly took some type inference in. Same with querying. The sort of like very core to most functional languages is the ability to query by essentially saying a function that takes more than one parameter is really a function that takes one parameter and returns another function that takes the next parameter, and so on. So that style of programming is very powerful in some ways and gives you very terse code sometimes, and very elegant code if you understand how to read it. But again, that's probably something that you can query things in C#, but it's not going to be sort of a native style, and it's not going to feel right, and it's not going to scale up to across methods and classes and stuff and be elegant.
Oh,
so yeah.
Another question from Fernando Carlos. Can you read?
Mm-hmm. Mads, do you think we'll use the new minimal API functionality extensively in production or just in POCs? Do you mean plain old C#?
Proof of concept.
Proof of concept. Oh, yeah. I think, the minimal API functionality is referring to efforts in particular in ASP.NET to create a default experience that is much, much simpler, has a very reduced surface area and concept count compared to what you get sort of dropped into today. It's fair to say that it has multiple purposes. One of them is simplicity for beginners. Like, let's not throw concepts at you and make you understand them until you need them, right? If you can get started with fewer concepts, we should let you do so. And then you can ramp up gradually if you want to configure more, or if you want to do more advanced things, then you can pull those concepts in as you need them. I do think that many people are not going to need all the concepts. And so it is intended to very much be a production experience that you can sort of gradually pull in some things, but then you can stay there and have a production quality developer experience, a production quality product that comes out of it. It's very much intended to be something that doesn't just simplify life for learners, but also for professionals. And a lot of this effort has actually, in the C# 10 timeframe that we're in right now, that we're finishing up, a lot of this philosophy has spilled into the features we chose to focus on in C# itself as a language. So we try to take more ceremony away from the developer experience, and we can, if we dip into Visual Studio in a little bit, I can again, show you some of that. So yeah.
Okay. José Silva question: why not remove the new statement from class constructor? I think C# 10 remove the new.
Oh, that's yeah.
Remove the type of the class, the new keyword not.
Yeah, you can now remove the type, but you can't remove the new when you call the constructor. It's something we looked at many times, and I think it's one of the things that if I was starting over, I would not require the new. I would do what you suggest and just let you use the constructor as a function call without a new in front of it. It's one of those things that if we do that now for all classes, it would be a massive breaking change to existing code. And if we only do it for new classes, or you have to opt into it, then it won't be very useful. So because all the existing classes won't be able to, including our whole core library. And so we've kind of given up on it, to be honest. I agree that it's one of those things that makes C# feel a little less modern. And we may come back to it. We're looking at a concept that we call factories, which are methods that are guaranteed to return a new object. It's not something that we've put into the language yet, but it's an idea that's floating around. And that would sort of have a similar feel to it, but you probably have to declare it, the factory, separately. So.
Mads, I have one question for you. I have some doubt about the OO paradigm that C# 10. C# along, if you saw a few years ago, is following the OO paradigm. But nowadays, it's not following all the OO paradigms, like the full implementation interface. You have class, records. Why the C# is not strong type with the OO paradigm? Why the decision that makes C# not a full strong with OO paradigm, classic OO paradigms?
A lot of that has to do with those influences from the functional programming languages. The OO paradigm is great when it's great, and it's not always great. There are some things that people consider to be part of the OO paradigm, but aren't necessarily, they're disciplines that you can follow, but it's not necessarily the only way to do things. And if you try to restrict the language to enforce those disciplines, you sometimes get into very rigid territory. So if you think about, the two things you mentioned, for instance, the interfaces. One aspect of interfaces in sort of classic OO that make them very rigid is that you can never add a new member to an interface without breaking all the implementers. Everyone who implements the interface is then broken, which means that interfaces in widely used APIs are locked in forever. And that we felt that was a big enough problem. We also, I have to admit, that's one of the features that we didn't come up with. We stole it from somewhere. We actually stole it from Java. And we felt that we needed to be able to evolve interfaces a little bit. And what default implementations do is they let you add new members to interfaces without breaking existing implementers, because if they don't implement it, you will. The interface will. So that was the reasoning there. I know that it's a feature that can be abused a little bit, and first people abuse it and use it to write super abstract classes, and then they complain afterwards that, oh, but the default members don't actually show up on the classes that implement the interfaces. No, because they're explicitly implemented. They don't show, so there's the feature, I think, is best viewed as it something that is only there to solve the problem of interface evolution. And if you try to bend it to other things, then you're probably going too far.
You have a point of view, because if you have a lot of code that implemented the same interface, if you add a new member, all the code is breaking because you add a new member in this interface. But the decision of make the full implementation in C# long is because to help the .NET team to improve new feature, to improve the productive, or just to add this functionality for our community to help you to design a no code or everything. This decision to help the .NET Core to improve the productivity, to add new features. This is the point of the full implementation.
Yeah, I think so. And one other thing that it helps us with that is a little less ideological and a little more practical is that it makes it easier for us to interoperate with languages that also have a feature like that. So specifically in Xamarin, it was important for us to be able to interoperate with Java, which has a similar feature, and Java, which has where there are like Android APIs that make use of the feature, and also with Swift and for Apple, for the Apple iOS stack and so on. So we're both doing something internally good for interface evolution, and it also helps us make a more faithful mapping to these other languages that also have this feature exposed in their APIs. So that was that was the reason why we did it when we did it, even though we didn't have a big need to evolve our own APIs at the time.
And what do you think Microsoft bring Java language to bring an implementation of Microsoft Java language? What do you think about this Java implementation, Microsoft? What do you think about this? Microsoft has implemented or have your own implementation of Java language.
Well, I think I don't have many opinions about it because it's more like a business decision to do so. Obviously, we want Java programmers to target our platforms, and we want to make sure that they have a good experience and that they have a very efficient implementation and not too many roadblocks in doing so. And having our own implementation, just helps with that.
Okay. I do think it's a more business decision than a technical decision to bring Java's on Microsoft stack?
I think it's somewhere in between, because Microsoft we've burned ourselves a little way back in the past trying to improve on Java.
Destroy Java. Dark side.
And we don't want to do that. But there are probably, implementation decisions deeper in the stack that other implementations might not be optimal for everything that you can do with Java on Azure, for instance. And I don't know the details of it, and actually I'm not supposed to know the details of it either, because we try to keep this work separate. It's not to
grow up the environment of the Azure and the support of the Azure, the experience of the developer that choose the language is more comfortable to implement some code, some solution.
Yes, yeah. This is really to support Java developers as best we can on Microsoft platforms. Yeah, that's what it's
okay. That's a lot of question. A lot of question. We'll talk about Java.
Great.
We have a lot of question. Let me see. That's a good question. No, it's a repeat question. Sorry.
What is the criteria to choose new features in a programming language? How do you choose or prioritize which features to add to the language? That's a great question, because that is like, literally, that is my job right there. That is more than anything, more than getting the ideas and more than, working out the details. This is sort of the core of the job. If I do this wrong, I'm not doing my job, and Microsoft is not going to keep paying me. So that's a great question. And I think that there's how it used to be, and then there's how it is now. It used to be that C#, like everything from Microsoft, was designed and developed in secret behind closed doors, and all the decisions were made by the time developers saw a new version of C#. That was how it worked when I joined Microsoft 16 years ago. And back then, we had a secret weapon, which was Anders Heilsberg, the father of C#, the first Danish guy to be in charge of C#. And he had and he has an amazing intuition about developers, had a lot of experience that he could bring in. And so he had, first of all, he himself had this intuition that would help make the right choices. And also he started a design process for C# that is intentionally collaborative. So we have a C# design team that is people from different physical teams working on different things that meet very often. Like back then, it was 6 hours a week we would spend together in a room designing C#.
6 hours to decide a new feature.
To decide on new features, from like the biggest questions to the tiniest details. 3 times a week, Monday, Wednesday, Friday, 2 hours each, we would sit in the same room and make decisions about C#.
It's not an easy job.
8 people or thereabouts, right? 6 to 10 people were on at any given time on the C# design team. And so he would instead.
Responsibility. It's a great responsibility because 8 people decide of millions of users of the language. It's a great responsibility to do that.
It is. And so by having the collective process in-house, so to speak, with lots of experience and lots of different perspectives that were free to discuss, and it was sort of centered around getting a consensus and a good decision process where even if you disagree with the result, you agree with the process that led to it. You agree that, okay, everybody else thinks this, so I'm okay with it. And that those two things helped us build a good, great C#, even though we weren't in public. But it really changed when we went open source, and Microsoft open sourced not just the C# implementation, but we also open sourced the C# design. And we have I don't know if you're all familiar. Is it okay if I share my screen?
Okay, no problem.
So we have a repo. Let me find it here. Hang on. Yeah, you probably have to put it up. There we are. Yeah. So we have a repo that's called C# Lang, and that's where all the C# language design happens. So we literally went completely open. This is where we keep all our files that have to do with the design of C#. Every time we have one of those.
The language has a Git list that anyone can add or.
Anyone can come in here, participate in discussions, and
suggest some new feature.
Suggest issue. They can suggest features as an issue if they have a detailed design. It all gets discussed in here, and it eventually becomes, proposals that are the documents that we built C# from. And this repo is just part of the openness of the project. Like I give talks like today where I'm willing to talk about anything that has to do with C# design. Nothing is secret, and everything's out in the open. And that means that even though we don't have Anders anymore, we have him a little bit, but he works mostly on TypeScript. We have the sort of combined experience of the whole developer community. And that helps us understand both, to come back to your question, it helps us understand both the things that are important to solve in the language, like what are people struggling with? What are where are the things that are too annoying to do in C#, and we should really think about a solution to it. And it also helps us get constructive proposals for those things. And it helps us once we are designing a feature and we're iterating on what should it exactly look like, should it, should there be a keyword, or should there be a squiggle, all those detailed design decisions. It helps us get feedback on those so that we can decide much quicker what is a good thing to put in C#. And this is instrumental to us making these decisions, and to us being able to do so now on a yearly cadence, where there's a new version of C# every year.
Okay, that the community is involved in that the decision where the feature is going to the language.
Very much. And we have community member features that sometimes features come from the community, and sometimes, most often, the community contribution is in the discussion around a feature once it's been proposed and in helping us get it right. And we also have community members that contribute to Roslyn, which is the compiler implementation. They actually built some of the language features in C# are built by people who don't work for Microsoft, who contribute as part of the open source project process as well. So this is how we get a lot of our feedback. And then, of course, your questions today are also the kind of feedback that I go like, oh, that was another one who asked about functional features, and that all of these things help give an impression of what are important things to focus on. Of course, we also spy on other languages and see what they do.
Okay.
If someone is, so we, you can look at functional programming language and you can be like, oh, pattern matching, we should have that.
I have a little bit guess that Java do the same thing.
Oh, they do. They do. And between C# and Java, there has always been a give and take. It used to be in the beginning that C# took more than it gave, and I think now it's probably the other way around.
Swift choose. I haven't spied. What's the C# language going to do? I have a doubt about this process of decision of a new feature of C# language. You have when to decide a new feature. Okay, this feature is going to be incorporated in the C# language. There's another process like MVP or early adoption about this new feature of C# language, a small group that tests this new C# language. There's okay, this feature is going to be on C# 10 or 11 or whatever, and it's going to be implementation. After the process of the decision of the new feature, what they're going to process? What the next process to decide to incorporate in C# language?
Well, then we have to go and build it, and we try we try as much as we can to build the features in such a way that there's time to try them out before we ship them finally. The more we kind of try to build features that we think will have more user feedback, that we think that there will be more controversy around or more open questions. We try to do them early and put them in preview. And there are a few different ways that you can interact with our early language implementations. We actually
there are any possible when we put this feature in the preview, you remove the feature on our next preview, for example.
Right. I mean, we have, if you look at, let me just go to Visual Studio here. If we go look at the project file for this, you can see that I've chosen lang version preview, and that means this is the production compiler that comes with Visual Studio or with the .NET SDK, in this case with .NET 5.0. But because I choose the lang version preview, that means that there are features available to me that are likely to be in C#, that we think will be in C# later, but we would like you to be able to try them now so you can tell us if they should be different or if they, if they stink and we shouldn't put them in, So that's one way, and we're trying to put more and more to do this for more and more features. So when C# 10 comes out in November, this preview language version will have very significant language features in it that are not officially part of C# yet, but that you can try and give us feedback on for a whole year until we actually ship it, and help us improve it. There are also smaller features, and some of them get built later in the cycle and so on. There's also, let me see if I didn't pull that up. There's SharpLab. I don't know if people know SharpLab.
No, I don't. I don't know this. It's a kind of site or practice.
Let's have a look. SharpLab is a website that it's not Microsoft that built it. It's other people that built it. They built it based on the public branches of the C# compiler that are in GitHub. So you can see here's the main branch from yesterday, actually. So that's pretty recent. That's the one that it defaults to. But you can also, here's let's see, file scope namespaces. I don't think that's in main yet. So if you want to try that one, you can go and just put that branch up. And over here, you can write some C# code that uses that feature. So file scope namespaces, that should allow me to say namespace my NS semicolon, and that puts the rest of the file in this namespace instead of you having to put curly braces around it. That's one of the C# 10 features. And you can go and play with it right here. And over here, you can see the results of running it, or you can see the IL that gets generated, or you can see the, whatever you want to see about it. So that's a great tool. We use it a lot in implementation. And oh, there we go.
Okay, very interesting. This site.
I did this.
Very interesting.
I did it wrong. And that's because, I think that's because the using has to be on top. Does that work? Or maybe, I don't know. But it's a useful, I shouldn't be doing this live, but it's a useful tool to know, try things out and see what's coming. But the nice thing about the preview language version, though, is that you just turn it on in the middle of your own production environment, and you now have new language features available to you. So you don't have to go somewhere else to try them. They're simply in your compiler.
Yeah, very interesting to test a new feature about C#. Very interesting. Can I send some kind of question of chat?
Go for it.
There are a lot.
We have 2 hours.
Okay, no problem. You can talk all the time.
Could you talk about the portable thread pool and why it was re-implemented as a managed in .NET 6 Preview 1? I can't actually. I don't have the. I just don't have the depth of knowledge around that. We in general, we constantly tinker with our APIs. And one of the things that has been a consistent, so I'm going to try to talk a little bit, but I can't talk about that specific decision. But one of the general trends is that we try to make C# and .NET better and better at building low-level components that need to be efficient, but low-level, in C# and in safe C#, rather than going to unsafe or going to interrupt with C or C++, okay? And then we make use of that by pushing sort of the boundary further and further down, where more and more of our own APIs are implemented in C# instead of in some underlying language that we have to interrupt to. I suspect this might be one of those, but I can't say for sure. Yeah, we'd have to ask one of the API guys. Stephen Tope would be perfect to ask this question if you can get him to show up in one of your following meetings.
Okay, I understand. Because you have a team that help and care about the C#. That the .NET Core, it's another team. You talking about features about C# and .NET Core. How is the process with the interface about other team, especially in .NET Core? You talk about what new in .NET, what new implementation of C#, what this interface about other teams in Microsoft?
There's not like a formal process, but we just talk a lot. More and more, we're actually getting better and better at this because we are more on a similar ship schedule, and because there are more and more things that we can change. Before we moved to .NET Core, for instance, there's very little that we could change in the runtime itself, because .NET shipped as a Windows component, and it was very hard to ensure that people, if you target one version of the runtime, very hard to ensure that people were running on the same runtime.
Oh, okay.
Now with .NET Core, we have the freedom to evolve the runtime, the core libraries, the language, and the tooling all together, right? The tooling meaning both VS style tooling, but also the SDK. And so we can collaborate a lot more, and we do collaborate a lot more. What typically happens is that there's one team that ends up being the sort of main champion for a set of features, but then we discuss, instead of them doing it all sort of in their own layer, we discuss across the teams to find out what is, holistically speaking, what is the right way to do this. Oftentimes, for instance, in the past, when we did a very complicated language feature like async, we knew that the runtime couldn't change. So we did a lot of very complicated code generation. The IL for async methods is very complicated because we felt we had to do it all ourselves. We couldn't collaborate with the runtime team on it. If we were doing async today, we would say to the runtime, hey, let's figure out what's the right thing to do. And maybe, half of the work would be on the runtime and half of it would be on the compiler. We would work that out together so that holistically we get the right result. And that happens. So now we actually do implement features in the runtime. For instance, the default implementations that we talked about before are in the runtime. Covariant return types, which is a small little feature, is one that if we had done it earlier, we would have done a bad implementation in the compiler, and now instead we have a good implementation in the runtime. We can do things the right way. Lots and lots of things have a core library component to them, but are a collaboration between language features and core libraries, and we do that more and more as well. We have some pretty complicated interactions that hopefully users don't see. That, for instance, we are building in C#10 where we are making interpolated strings faster by having a very delicate dance with the core libraries, that if they expose certain builder types in a certain way with certain attributes, the compiler will recognize that, and it will generate more efficient code for building the interpolated strings. So that if you have a very heavily visited loop that builds interpolated strings all the time, you can save some cycles and get some performance.
Okay, I understand. It's a very difficult intersect about other team, especially with runtime, because if implementation you add a new feature, you can broke in the runtime, and the runtime implementation can broke in the C# language. It's very difficult because that it's very, very difficult. I imagine that's very, very difficult to compile a C# and transform in EL language, and that they run all the thing all the time in runtimes. .NET Core 3.1, 5, 6, and you have to make the compatibility about all this runtime. It's a very difficult job to do that.
It's very complex. We're building a feature right now that will be in preview and C#10, and we hope for it to be in C#11. That is, it's actually a couple of features that are built for each other that are about essentially the core idea. I can actually show you. Let me put a slide up here. That is about. Hang on. Skip that for now. This one here. It's about being able to write abstract math. Okay, so writing code that is generic over the type that it's working on, but it's using proper math operators, and it's very hard today to write code that abstract algorithms essentially in math, and so that is a problem that we intend to solve in Dev 11, and it's really a combination of deep runtime work, deep language work, and deep core API work that all come together. Here's sort of a little teaser version of it, if you will. The core feature again challenges what can be in interfaces. So object-oriented purists will not like this. But what we chose to say is that interfaces can now specify static members.
Static member interface.
Yes. So it's a static member without an implementation. And what it says is that classes and structs that implement this interface, they have to have these static members. And of course, one kind of static member is operators, right? So we have operator and a plus operator here. Here's a static property that gives you the 0 value. So this is an idea of something that can be added. It needs a neutral element and it needs a plus operator. This is expressed.
O add diz functionality of C#11.
This is C#11. So this will not work today. But when the C#10 compiler comes out, you can choose lang version preview, and this will work. This is something we have implemented now. It's just we need time to bake it and make sure that we're doing it completely right. So we're going to ship it in preview in C#10, make sure it all works out, and work out all the kinks, and then this will be C#11 surface area. So the runtime the compiler has to understand static members in interfaces. The runtime has to understand static members in interfaces and their implementations. And the core library has to provide a set of math interfaces that make sense and that everybody can implement, but we also have to implement them on our own primitive types, so that int, for instance, can implement iaddable of t. Okay, so here's int implementing this interface. So we'll go and add this implementation to the core int32 type, and specify that the plus operator is int's plus operator and the 0 is the 0, and implement these static members. And how do you then use them? Well, now I can write a generic algorithm that takes a t, and I can constrain the t by this interface, and only types that implement this interface and therefore have the right static members, they have a plus and they have a 0 as static members, can be passed as type arguments. So I can call it on int. It's inferred here. It's an array of ints. We infer int as the type argument. It gets passed to the generic method. It satisfies the interface, and so we can get the 0 from int, and we can use the plus from int generically inside of this method. But if you want to write your own API, your matrix, a complex number, or whatever you want that does add, you can do that too, and you can still call this method that will then take an array of those things and sum them up and return the result for you.
Very interesting.
So this is
very different too.
This is the kind of thing this is a massive addition to the .NET user story all up, right? C# sucks at math today because it's so tedious to write anything generic, and now it's going to be great, right? It's going to have super expressiveness in terms of math because we can work together across all of these teams and carefully design the right language features, the right runtime support that's efficient, the right libraries that provide good abstractions around math, And yeah, this is really sort of like I love this project because it really showcases the things we can do now that we're all together and on .NET Core and by collaborating. So
yeah, very interesting. It's very. I have to confess, it's a very different feature to have a static abstract interface. It's very different about any language, many or paradigm. It's very different.
It is, but it's not unprecedented. If you look at, I think if you look at Rust, what do they call them? Whatever their interfaces are called. They're not called mix-ins. They're called, I can't remember right now, but they have they have a similar capability, I believe. And one thing this is actually also ultimately a bit inspired from functional languages, because if you look at the most exquisite of all functional languages, Haskell, it has a thing called type classes, which also lets you abstract over the operations on types. And this is sort of has similar, not quite the same, but similar expressive power to type classes in Haskell.
I have to say exactly. Haskell has the same capability. You have abstraction of the over the operation.
Right.
Okay.
So it's not that strange, is what I'm saying. But I do want to say one of the things that we have to, I think a lot of people, when their thing gets popular, they get scared and they want to make sure they don't make anyone angry, and so they get very careful. And we're careful too, but we don't want to be so careful that we don't innovate. I think you see some languages, and I'm not going to mention names, where there's too much risk aversion and they kind of fall behind. We want to find the right balance where we are sometimes we are the language that innovates and that goes where no one has gone before, or does it in a new way that nobody has done before. We want to be comfortable doing that. It's part of our language. Actually, hang on a second. It's part of our language strategy. We actually say so. Let me see if I can find, here we go, the .NET language strategy. It's on our blog. It's 4 years old. And we specifically say for C#, this is what you can go here and read. How do we think about evolving C#, Visual Basic, and F#? It was a pain pulling all this together, but it's actually great. We keep going back to it. We say we will keep growing C# to meet the evolving needs of developers and remain a state-of-the-art programming language. We will innovate aggressively while being very careful to stay within the spirit of the language. So we really mean that. We will invent new things and we will stick them in your language, even though we have millions of developers that depend on us. We have to have that courage, or we will die a slow death of falling behind the curve and not being the best language for new challenges and new domains, and compared to other languages. So something we take very seriously.
Yeah, I understand. It's kind of a mantra in C# language. We're going to innovate the C# language.
But you can also, yes. But you can also see let's look at the whole language strategy now that we're here. You can also see that there are other things that that's not the only mantra we have, right? We also say, we also say there's such a diversity of the developer base that we prefer to make language improvements that benefit all or most developers instead of focusing on a specific segment. So we don't try to make C# just great for one thing, and we try to not put features in that are just great for one thing. So I showed you the statics in interfaces feature just before, and it's great for math, but we don't want to put in a feature that's just great for math. And so we think that statics and interfaces are a general enough abstraction feature that it'll be good for other things. It'll be good for abstracting over constructors, for instance, and that kind of thing, or creation of objects. But it's also like to say, we don't want to just, we don't want to, maybe we put in a little feature for Xamarin or for Azure or for Entity Framework or whatever. But generally speaking, we will try to make language features that are good for many people.
Okay, it's a very, very interesting mantra. And I have another. Sorry.
Yeah,
continue.
I just want to do the last one here as well, which is sort of highlighting what we talked about before, which is empower the broader ecosystem and grow its role in C#'s future. That has really played out in the intervening 4 years with the GitHub site and the masses of input and engagement that we get. So I wanted to point that out as well.
Mads, can you send me the link of this page in the private chat? I will send it for our chat.
Absolutely. Yeah.
Okay.
Yeah. Feel free to share these, obviously, to the. I can't put it in the public chat, I think, but I think you can.
I can.
Yeah.
Send me.
There we go.
Okay. Thanks. You have another question about what do you think about Geek Coplot?
Could it make us more productive or lazy? So lots of people have opinions about this currently on a vast spectrum of like, this is garbage. This is going to have to break open source licenses, and this is great. It predicted my whole algorithm to, depending on how people actually experience it. I haven't played with it myself yet. I think it's interesting technology. Much as we like to innovate, there are many problems that have been solved before, and to the extent that you can use machine learning and good tool integration of that to predict what you probably should be doing, stand on the shoulders of giants. Somebody did this before. Why not reuse the result? As long as they're okay with you reusing it, which, they only train it on open source. So I think it's interesting technology. I think it is, it's not really very dissimilar from things that you're starting to see in natural language writing as well, where you have tools that predict the rest of your sentence and try to do so in a non-intrusive way, where it doesn't get in your way, but it lets you, move faster. I'm fine with that. I think there might be all kinds of hiccups in the beginning, but on the whole, I think this is going to gradually morph itself to the most useful, productive place. And I actually think I think as a technology, it's promising.
Okay. I have some with the technology, but I think I have my own opinion about GitHub Coplot, especially when training the GitHub Coplot. How this training about the Coplot. I have some bad news about some news in the developers community about GitHub. How it's training Coplot? How training the machine learning about GitHub Coplot? How the data set has been formed to training GitHub Coplot. Some kinds of news that the Microsoft training GitHub using open source code hosting in GitHub. I don't know if it's true or not true, but I think it's a very interesting functionality. But I think in the future you can, how can I say, that made developer lazy and be turning the developer more lazy, or made the developer not so researcher that the developer can want to be.
Yeah.
Because you write some kind of code and the GitHub Coplot write all the things.
I think that is definitely true. And as a language designer, there's something else that I'm worried about, which is I build new ways of doing old things sometimes, right? This new, sometimes it's just syntactic sugar. Sometimes it's really a more expressive way. If the training is not done very carefully, then a tool like that will be biased towards old ways of doing things versus new ways. And typically the new ways will be best, right? So there are all kinds of, I'm not saying this is all great, and I don't know yet. I haven't really played with it, but and just every time you train something, even a source code predictor, you have to look at the bias of the data set that you're training on. Bias in this case can be for old clunky ways of doing things. It can, that's one kind of bias, but you have to think about what other kinds of bias are there in there. Maybe bias that are more the more goes towards bias between people that are different. All the comments using he and not she are all, are there assumptions about, are there geographical assumptions? Are there other assumptions in there? Even code has, plain text, and does that, how do you make it bias free? Even there, it's probably not the worst place, but it's certainly something that many tools have struggled with, that essentially they work great as long as the person using them is like me, a white middle-aged man living in the US, right? Once all the tools, all the artificial intelligence tools work great for me because they were all trained on people like me. So that's a broader question on AI. I don't think that things like Copilot will be the most susceptible to that, because data set has probably less bias about people in it, but it'll have some, and it's also something to worry about.
Oh, okay. No, I understand. I agree, but I have some concern about the GitHub Coplot, just because of how they read the data set, collect the data about the GitHub, with not the concern about the owner of the public repository. Right. I think that's the case, the question.
Right. And you don't get me to discuss that kind of thing too much, right? I work for Microsoft. GitHub is Microsoft. I can't speak on their behalf.
No, okay. I think it's not being going too long about this talk. I just think GitHub Coplot is a very interesting functionality, but I have some concern. That's the point. Let's move on.
Cool. Oh, so here's a question. Is it possible to implement a monad in C# like it's done in F#? So that's probably, monads are probably another place where I don't know if C# is going to get a generalized monadic feature. And if you don't know what monads are, that's fine. I'm not going to go into details of it. C# has a special case monad feature in it, which is language integrated query. So there's essentially, when you write a query expression, it's monadic, and the way it translates into function calls is similar to what monads do in a functional programming language. That's as far as I'll go. I don't know that. I'm not going to say that we're never going to have a generalized monadic feature in C#, but it has not really presented itself as the next thing the developer needs. So I wouldn't say anytime soon. You can abuse query expressions to do any monadic thing you like. C#, the syntactic translation, so you can build types and that offer the right, projection and whatever, the right methods on them that you can implement whichever monad you like, as long as you're okay with saying from blah, where blah, select blah to run your monad, which is may not feel. It all feels like a query, even though many monads are not about queries. So you can, but you won't like it. I think it's the answer.
I think you answer about the blog site when the strategy of C# language, but what's the main goal of C# for the future? What do you think about the main goal of C# going to the future?
So I guess live long and prosper. I think that it's useful to sometimes stop and think about how does it end for C#. You know, I think that there are two ways that programming languages die. One of them is that I already discussed that we are trying to avoid, which is that you fall behind. Eventually, people only use the language on code that they're maintaining and not to build new code. And you sort of become a legacy language. And from then, there'll be fewer and fewer C# developers. They'll be paid more and more to maintain the code bases that are still around. But it's it's a death march. Essentially, the language atrophies to death. The other way a programming language can die is bloating, is that it becomes so big that nobody can master the whole language, and it doesn't feel like the language doesn't feel unified anymore, and it takes too much of an expert to use it. That's probably more likely to be the way that C# dies, given that we're leaning into innovation so much. That's the greater risk for us. And so it's important for us, even as we try to add a lot of new functionality, that we try to do it in a way that has as little negative impact on the language as possible. The lowest concept count, the lowest syntactic overhead. Many features, we try to make things that fit in naturally, where it's almost like there was a thing missing and we put it in and the language became simpler. And so the goal really is to keep being a language that you would choose for your next project for as long as we can. That's probably the one sentence answer to your question.
Yeah. And talking about that language that will die or will be die, that's the language maybe I said that walking that language. What do you think about Visual Basic language? What's the real reason to come back with Visual Basic language? To kill Visual Basic language?
So
now it's returning. Visual Basic returns, no?
So Visual Basic is not dead, to be clear. How it is not. I mean, we invest resources in Visual Basic in every cycle, but the Visual Basic language, we've decided not to add new language features to it as in new syntax. That Visual Basic is intended to be a language that is accessible and simple to use. And if we keep pouring advanced new features in like we do in C#, it's going to lose that flavor. And it's not really going to be useful.
You are the lead of the Visual Basic language feature, or it's some other team?
I am not. That's Kathleen Dollard.
Okay.
But we work very closely together, and Kathleen is on the C# language design team, right? So we talk about, and if you go and read the Visual Basic language strategy in that same place that we just looked at the C# one, you will see that come out, that we want to keep Visual Basic being this accessible language. We want to keep it at the level that it is in terms of its own expressiveness. And that means that when but we also want, but there's a countervailing factor, which is that we want it to stay a first-class member of the ecosystem. And what we mean by that is that when we add a new feature into C# that lets you declare something new, a new kind of thing, then we make sure, then Visual Basic will not get the same feature to declare it, but we make sure as best we can that you can consume it from Visual Basic. So if people make libraries with that use that new feature, then consuming those libraries from Visual Basic should still be a first-class experience. That means that there are language features that Visual Basic understands how to consume with existing syntax, even when it doesn't allow you to declare them. That means that libraries may not be, that you may not be able to write the libraries in Visual Basic, but you're able to use the libraries from Visual Basic. It's an end-user language. So that's one of the ways that we try to balance that. We don't just leave it adrift and say whatever happens, happens. We keep it as best we can. And if we don't live up to that, let us know. You know, we keep, as best we can, we keep it a first-class consuming member of the .NET ecosystem. And we also keep the tooling first class. And the whole Roslyn language engine continues to be a two-language thing that handles both C# and VB. So that is that's how we think about Visual Basic. It's not. It's been a bit of a. It's not been a good thing for a while for Visual Basic to Visual Basic to users to try to measure Microsoft's love in terms of how many new features we added to the language. Because that hasn't been a good thing for Visual Basic to add that many features. Instead, try to look at how well we support it and how well we keep it a first-class member of the ecosystem, so that you can continue to build apps with the best tooling and consume APIs in their full expressiveness.
Okay. Another question is about Mads can read.
Okay, yeah. Mads, you once said, oh, people really tracking what I said, huh? I should be more careful. Is this being recorded? Mads, you once said that you had a lot of interest in discriminated unions for C#, and now that records are under control, we'll focus on it. But it won't make it to C# 10. What is lacking for it? This is a really good question. I think we have a bit of an existential question around what do we mean when we say discriminated unions in C#. So again, discriminated unions are a feature that functional programming languages use to express when it's possible for a value of a given type to have different shapes, right? And in some ways, it's functional programming languages' alternative to inheritance. In an object-oriented language, when something can have different shapes, you inherit and you make those different shapes derive from the base type. And in functional language, you write a discriminated union, which in one place lists out all the possible different shapes for the type. Okay, so those are similar, but they're also in important ways different. And the question is, can we, like a few languages have had some luck with trying to unify the object-oriented and functional perspectives around where discriminated unions are integrated in an object-oriented setting. Like in Scala, discriminated unions are sort of a form of inheritance, if you will. But we're not really sure yet what we want to achieve if we do discriminated union. Is it just a matter of having have syntactic sugar for declaring inheritance? Is it important for them to be more expressive in some ways? Is it important that we can check, for instance, discriminated unions are a closed list of things. It's important that we check that that a switch over discriminated unions is complete, that kind of stuff. We're not sure yet. So we're still essentially gathering feedback. If you have opinions on it, sort of at the next level, not just I would like discriminated unions, but what is it that you would be able to solve better? How would your code be nicer if you had them? That kind of input is useful to us currently. We do have discriminated unions sitting on our work list of things that we want to look at. We haven't made it to them yet, partly because we're not quite done with records yet. We're not as done as we thought. We keep refining them based on feedback and so on. So we're not ready to take the step to discriminated unions, but also because we don't fully understand what is it actually that we want to do with them.
Yeah, I understand. You have a lot of questions about very, very feature of C#. You want to present something, or can pass the questions?
I mean, we can go either way. We could go and look at a few features in Visual Studio and talk about them from that angle. Or I'm happy to keep answering questions. It really depends. I'll leave it up to you, Rafael. What do you think is...
Okay, you decide. If you want to present, I can track or save this question at the end, pass the question, or if you want to respond, answer the question, we decide. You're the boss.
Okay, why don't we spend like 15 to 20 minutes in Visual Studio and see what happens?
Okay, nice.
And then take it from there. So let me. So do you want to talk about? Okay, let's go here. I don't know how up to date everyone is on C#. There's a new version every year now, and C# 9 has been out for a little over. It's probably been out for 8 months now. So it's still fairly young. C# 10 is still being worked on. But maybe we can talk about, there's been a lot of interest in some of the functional things. So let's talk about some functional concepts that are making it more into C#, around first-class support for immutability and sort of a value-oriented approach to programming, as opposed to object-oriented. So it's sort of like looking at some of the functional alternatives that are making it in. We just touched on records, and I want to remind people who are out there, maybe haven't looked fully at it yet. I want to remind people what that is, and I can also mention how we're taking it a little further in C# 10. So let's start out by talking about immutability. And so really, one of the things that functional programming languages have pioneered is a worldview in which objects don't change or values don't change. And it's really good for representing point-in-time data. So if you think about a database, like here's a little bit of data. I actually changed my last name to my wife's last name when I got married. And so when I was born, this was my last name. But then later, I mutated, the object Mads mutated to have this last name instead, right? And so that's classic imperative programming. You mutate the object as time goes by. And at any given time, the Mads object represents what I look like right now, what the data about me is right now. But it's also destructive, right? It destroys knowledge about what did I look like before. And so if what you're building is a record-keeping system, then this is not a good thing, right? You're destroying old records. Instead, what you want is representing the data about me at any given time, which means that by the time I got married and got a new last name, there should be a new record describing the new me, so to speak. And you want to prevent the old me from being mutated and being destroyed. You want to protect the integrity of that data. And so that's kind of a core functional programming paradigm. And we want to support that better in C#. So in C# 9, we did a couple of things. The first one we did is to say, okay, how can we support this immutability thing? It would be great. I mean, we already have the ability to not have setters in auto properties here. So we can take the person class and just remove the setters. And now it's certainly immutable. But unfortunately, it's so immutable that I can't even use an So you see, it prevents me from destroying it. That's good. That's what we want. But it also prevents me from using object initializers on it, and because they rely on mutation. So we were like, that's okay. That's a bridge too far. That's too harsh. We want object initializers are great. They're beautiful syntax. Many people love them. They have good code maintenance properties and so on. Let's not make immutability and object initializers mutually exclusive. Let's make them work together. And so what we said in C#9 is you can write a special version of your setter that we call the initter for initialize. And that is a setter that only works while you're initializing the object. So it works here in the object initializer, but then it becomes illegal to use after the object has been fully created and initialized. This gives us the right level of immutability to flexibly, to combine immutability with object initializers.
This keyword init is different for C#9 because init in C#9 it's for field. Now you can use in property init.
No, this is in C#9.
Oh, okay.
This is something you can do in C#9, and I'm using auto properties here, but you can also write your own. Just like you can write your own setter, you can write your own initter, it's really the setter, but the difference is that it's forbidden to call it. It's forbidden for it to be used after this end curly of the initializer, so to speak.
Oh, okay. Because I thought that init so only can use in fields, not in property. Because I asked about that in C#10. This C#9 because okay, I understand now.
We may have changed it. If you asked before we shipped, there may have been some evolution there. But init actually is specifically for properties. One thing that, and we could talk a lot about what exactly is allowed actually, and if the if the object has a read-only field, so talking about field, read-only string, first name, then, a setter would not be allowed to assign to it. If I say fn equals value, it wouldn't be allowed to because it's a read-only field. So you see the error here. There are other errors, but read-only field cannot be assigned in the setter. But because we know that the initter only gets called when the object is being created, we allow you to assign to read-only fields from it within it. So it kind of it maintains that read-onliness this way. But let's go back to the simpler code here. There we are. So that's the first step. Now we can adequately protect our data from being mutated. But then what do you do if you want to produce that new record based on the old record? Like, let's say that there were 20 fields of data about Mads, and we only wanted to change this one. How can I create a new Mads that's like the old one, but with the thing changed, like what we call non-destructive mutation? Well, that's something that we decided to support in the shape of what we call records. So record is a modifier that you can put on a class of struct in C#10. You can also, when you put it on a class, you can leave out the class. That's the default for records. And actually in C#9, that's the only way you can write it. But in C#10, we will allow you to say record class and record struct. So it's a modifier on class. Let's think about it like that. That makes the class value oriented. It gives it things that treat it more like a value and less like an object. And one thing that it gives it, and we can look at what those are, but one thing that it gives it is the ability to do non-destructive mutation. The way that works is that I can say var new Mads equals Mads with, so there's a new keyword plus with that you can use here. And then you can put an object initializer. That could be, you could put more than one property here, just like the object initializer up here, but you're using it to initialize a new object that was first copied from the old Mads. And then, so the record has the machinery to copy the old Mads object and then apply these changes on top of the copy. And that's what non-destructive mutation looks like in C#. And now I can display the new Mads here, but I could also display the old Mads after I created the new Mads, because they both exist. I have a record of the before and a record of the after. So if we go and run it, and if I did my thing right, that was slow. What's going on? There you go. Both Madses are there, and you can see it copied over the first name and overwrote the last name. But those two objects are now both in there, and they're both values. They don't represent me. They represent me at a certain point in time. So they're a value snapshot of the state I had at a given time.
But he clone or create a new object?
It creates a new object. There's
clone the values.
And it copies all the values. When you put record, when you declare record, it implicitly declares a copy constructor, a protected copy constructor that will take a new object, take an old object and copy everything out of it, then call the base copy constructor with that object and so on. So it's a very straightforward copy constructor that essentially that the with uses to create the copy. We chose to not just use cloning, because with the copy constructor, you can actually, if you want, you can go and write your own and mess with the way that, if you're really advanced, right, you can mess with the way it does it by declaring your own. So that's one thing that records do that are very value based. You can copy and modify with the with expression. And then there are a few other things. A silly little thing is that they have a better toString that actually uses the values. So instead of display here, I could just say console.writeLine, and it would write something reasonable. We can do that on both of them. So console.writeLine, and we have generated a reasonable override of, let's just go and look at it, reasonable override of toString. So that's also value-based. You can see that's the result of toString on a record. But then finally, we also, now we can throw this thing away. Finally, we also make the equality value-based. So when you compare two objects for equality, if we console.writeLine, Mads equals new Mads. There we go. By default, that's a reference comparison, but on a record, instead, it will do a value-based comparison. It will go to all the fields, just like when you compare two structs, actually. It will compare all exactly the same way. It will compare all the fields recursively and give you the result of the ANDing all those together. They will still be different, but if let's say that we created a old Mads that's the new Mads with the last name changed back. I don't intend to get a divorce, but oh, sorry, I forgot to put the with, but that's what would happen maybe if I did. Last name equals Nielsen again. Then and I compare the two, then even though old Mads is a new object, that's the different object from Mads, because they have the same values, the equality will compare them and say that they're the same, that they are equal in value.
Because it compare the value, not the point.
Exactly.
Not the address.
not the address. Okay. So that's a core of records. As I said, we did a few more things for records in C#10, or we did them, but you don't get them yet. I mean, they're in preview. A record can be a struct. That's great. And this all still works. So that means that the equality operator and so on still gets generated for you. We can also, actually, the non-destructive mutation, if you think about it, all structs are very easy to copy. Whenever you assign a struct, you're copying it. It's built into the language. So we said, why should that only work for record structs? That could work for all structs. So we actually made it so that you can use with expressions on all structs. Now, structs don't have an equality operator, and we didn't change that, but the with expression is still not an error here, you can see. So any struct that you already have, you can now do non-destructive mutation on if you want to. That just works. There's one more thing that works, which is that, but I don't think it works in this preview, which is that if you have anonymous objects, the with expression will also work on those, because they're really just sort of like records as well, anonymous records, if you will. But that's not in this preview, so we get the red squiggles.
But this feature, you will be in another preview or C#11?
This will be in C#10.
Oh, okay.
It's just not, I don't have all of C#10 here yet. I don't have a build that brings it all together yet. So
okay.
But this will be in C#10. Okay, so that's a few things. Any questions related to this, to the records or immutability stuff?
Yeah. We have one questions. Just a moment. Is the copy on records with a deep copy?
A great question. It's not. Essentially, it's the same. It's the same as what struct assignment does. So if you think about when you assign a struct, if it has structs inside, they will also get copied because that's how you assign structs. But if you have references to objects, you will copy the reference, not the object. And we decided to just look at what structs already do and have the same functionality by default. Again, you can go and tinker with it if you want it to work differently, but that's sort of like advanced stuff. That's when you like built the whole thing on records and you're like, oh, this one little thing doesn't work the way I want it. I will go and tinker. I will go and put my own copy constructor in and do it differently. But by default, they are a shallow copy, essentially, in the sense that they will copy structs and they will copy references to objects.
Okay. There is, I think, it's a good question. Are there a new IL language to support the C# new feature, or you use the same IL instruction set?
Usually we use the same instruction set. I don't think we've actually added to the instruction set yet in any of the new, even the features that get runtime support. But we have added, if you think about, but IL is really many things. It's a set of instructions for the actual code, and then it's a set of allowed arguments to those instructions, and then it's a bunch of metadata as well that describes the classes and all that stuff. And when it comes to the metadata, and in particular, and the allowed arguments to some of the IO instructions, that's where we have sometimes added things. And then sometimes it's really, so for instance, if you think about the statics in interfaces, that's a place where, yeah, there's a bit for static that just wasn't allowed to be set before in interfaces, and now we just allow that bit to be set. So we extend the language, if you will, but it's not by adding a new instruction, or it's just by no longer disallowing a combination of bits. So oftentimes we can get away with that, and sometimes we need a little more surgery, but so far we haven't had to invent a new IL instruction yet. We might yet do so. The statics and interfaces let you do constraint calls in new places that you couldn't before, and that's how that one will let you invoke static members inside of a generic function.
Okay, and there's a sorry, no. That's the question. What's the relationship between Visual Studio, Visual Code, IntelliSense developer, and C# language development?
Well, the relationship really goes through the compiler mostly. We do have, we have a lot of different teams represented on. I said that we have the C# language design team, and there are people from many teams on it, and one of them, Cyrus Najmabadi, he works on the IDE. So we have a direct relationship with them in the sense that we talk about how language features should be supported in the IDE and how to design a language feature that lends itself well to support in the IDE. So we have good crosstalk between the teams. In terms of implementation-wise, Roslyn is the C# and VB compiler, and it has a lot of support for language understanding and language and code manipulation. That's sort of in the core, and the IDEs are built on top of that. So whenever we implement a new language feature in the compiler, we also expose these handles, these bells and whistles, for the IDE to take advantage of to create the IDE level experience, the completion and navigation, the refactorings and diagnostics and all the kinds of stuff that happens at that level. The compiler, the Roslyn compiler is really much more than a compiler. It exposes all those things so that it's relatively easy to build IDE functionality on top. And that means both Visual Studio, VS Code, other editors, if they want to, can all reach in and get that core functionality from Roslyn.
Okay, and the Visual Studio Code, Visual Studio Quem plugin Roslyn compiler and show these new features in Visual Studio Code and Visual Studio normal Visual Studio Code in the same time.
Yeah, I mean, there are two different code bases. At the IDE level, or the tool integration level, the work is not necessarily done by the same people at the same time for VS versus VS Code. It's not the same people who do it necessarily, but the core, they all built on the core Roslyn expressiveness.
It's not the same time. If you want to present more functionality.
I want to show some a general trend that is that something we've done a lot of in C# 9 and C# 10. It kind of relates back to the question in the beginning about the simplified APIs in ASP.NET and so on. It's really that it's time to simplify the developer experience. It's time to make things simpler that are simple. Simple things should be easy, right? They should be simple. And so there's a lot of opportunity for reducing boilerplate in C# code. One of them that we addressed in C# 9 is this notion of a main program that has to live in these two levels of wrapper declarations. Like if you're someone learning C# for the first time, there's a lot of stuff that you have to learn how to ignore in order to write your first hello world. And we kind of just want to get rid of that. So what we said in C# 9 is let's let you just not write that. You can just write, let me put, just to make this, to remove the last red squiggle, record struct. Let's just let you put the the program on top here. Oh, that's not what I wanted to do. There we go. And so you can now write your main program at the top level of one of your source files instead of having to put all the boilerplate around it. That's just a simple thing that makes this look more like a 21st century language. People by now coming from other languages are expecting this, and people coming to programming for the first time don't have to be confused by boilerplate that used to be maybe state of the art, but certainly isn't anymore. So that's one example of us just simplifying the language. Under the hood, it does much the same thing. In C#9, it generates just as an entry point that you can't name. Actually, in C#10, we're probably going to change it a little bit so it actually generates a program a class called program with a method called main. So you can still call it if you want, but you don't have to write it. That makes it a little more testable. We got some feedback that what we generate for this isn't testable enough, and so we'll change that. But we'll change what we generate. But the main point is you can now just write a program at the top level.
Do you think that this kind of code can be in the future turned on with C# script? Like you can create script for PowerShell or create script for another bash like Python?
You know, it's possible. I don't know if you want to go that far. Maybe. I mean, people have played with that. We do actually have a scripting dialect of C# already that we somewhat support, and that also allows for C# interactive behavior, where you like type a statement and you can inspect the changes and type, make declarations and on the go in an interactive fashion. It's a little, and the C# scripting dialect has had top level statements for a long time. And it's a little bit unfortunate that they're two different dialects. I really regret that. And so I think over time, you will see us add more and more things to both dialects until they converge and become the same, or as much as possible, become one language again. I regret that we let them diverge almost a decade ago. And over time, we'll probably opportunistically bring them closer and closer together.
Okay, it's not main goal to transform C# in C# script language. Like you have the language.
No, it's not the goal, but the goal is that you don't have to understand class declarations. You don't have to understand methods. You don't have to understand all that when you write your first line of code. You can just write your first line of code, and it will do something.
Just about where the curve of learning C#.
Right. But I think that I'm certainly not going back to writing main methods the old way again. Like I think as a professional developer, this is still superior, right? It's just easier to read, and it just doesn't hide in the corner somewhere. It's like the code is right there. So I think that's probably, I would just recommend that people use this from now on, unless they're very, very specific things that they can only do. There are very few things that you can only do if you have a main method.
Yeah, it's a very interesting, because I'm a teacher in Rio de Janeiro. I have some kind of students that don't see any kind of language. It's starting to the college, start to learning program. When you see C# or Java or whatever, C# especially, you have a lot of doubt. Why you need to create a static void main? Why static? Why you have parameters? When this kind of code is very easy to explain how to. Let's do a hello world, a classic hello world. Just console, write line, hello world. That's ready your program. It's very easy to explain that a student that starts to learn program. It's very interesting functionality. I think
I was muted there for a second.
Yeah.
I was just chewing a bit of chocolate there to keep the sugar up. So that's exactly right. And we try to keep this viewpoint going into C#10 as well. So a few more things that we are trying to do to make code simpler. also in C#10. One of them works in this preview, and one of them I think doesn't. The one is about using directives. So that's a lot of stuff to have on top of your file there. Every file, right? To import things that you are using, and these are the common things that everybody probably want to have available to them. Now, in the past, we've said, well, yes, it's a lot to have in top of every file, so we give you really good IDE features to remove the ones that you don't use, right? You can remove unnecessary usings, and okay, now it's shorter, but now it's different from file to file, depending on what that file used, and if you need it later, now you have to know to go and add it back again. And so this is really not a very nice experience. What we decided to do instead is to add global usings. So if I go, let's see here, I have a file that just has usings in it. Let's go and do see if I can figure out the right fingers for this. If I go and say global using, now I'm declaring usings that apply throughout the whole project, like the whole assembly. These usings are for everyone. So you can have just one file where you put all your usings, and then they apply to all the other files. And now actually, if you see here, I get a bunch of warnings saying these using directives are unnecessary because they're declared elsewhere. So I can just go and delete those, and that means my programs don't all have to be cluttered with usings. We think that it's a simplification. Some people say, well, I like to be able to see at the top of my file what's being used, and I'm like, okay. But we're probably going to remove this warning from the final release, so that if you do want to repeat yourself about some things, we will still let you. We're currently doing work to remove that warning. I hope that makes it into C#10.
There are any plans to use global using to be a default file when you create a template of AFCnet.NET Core, and there are a file with global imports, global using.
They're currently working on that. There's it's possible that some of that will happen not by adding. We're currently, actually today we were discussing because they might add it more like a thing that you put in the project file, or they may end up that the template just put this in. Like if you use a console template, it will put these 5 usings in, global usings, in a file, and in a .cs file. And because then if there's one of them you don't like, you can just go and delete it from that source file or comment it out or whatever. If you don't want it to be global, you can just turn it off. But the details of that are still being worked on. So I can't tell you exactly what that looks like, but we are looking for already in the C#10 timeframe for the tooling, the templates in the tooling, to put a good set of starter usings in as global usings. So you can imagine when you get to ASP.NET territory and maybe you have 13 of these, 17 or whatever people get to, that would be a real help, right? You get some in from the template, and the rest you can just add to one file instead of all your files, and it's sort of off to a side. If you're interested in what they are, you know where to go look. But other than that, they're out of your face, and your program just got simpler.
Yeah, much simpler, cleaner.
Right. And then there's one more thing. Let's say, for the sake of argument, that we take this. Let's take this type declaration and put it in its own file. I have a file ready for it here in some namespace. Pretty much everything you write, except for your top level program now, pretty much everything you write in practice is inside of a namespace. Like the vast majority of code in the world is inside a namespace.
Yeah.
Also, the vast majority of source files have only one namespace in them. Like it's very rare that you have a single source file that has 2 or 3 namespaces after each other, or has them nested inside each other or something like that. It happens and it's fine, but it's just not very common. By far the most common thing is this: you have one namespace, you have some type declarations, end of story. So all the code is indented in your whole file. Like you're just wasting apart from the first 2 lines and the last line, we're just wasting these typically 4 space, whatever your indentation is, you're just wasting that. All the code, boom, goes, all the relevant code is to the right. Where what you really want to say is just, this is the namespace for the whole file, and everything that comes after lives in that namespace. That's what you want to say. And this doesn't work in the preview that I'm currently using. So you see the red squiggle there, but this too will be enabled in C#10.
And this record, this type of person inside people stuff namespace.
Yeah. So everything after this namespace directive, if you will be inside. That's what this means.
Okay.
But you don't. So it's the same as before, but you don't have to indent.
Okay. The same, but don't have to put the brackets.
Yes, this is syntactic sugar. That's all it is.
Okay.
There's nothing deep about it, but oh my God, it saves a lot of indentation. If you look at, so essentially, the using lets you save space vertically, and this namespace directives let you save space horizontally. So that's the kind of thing that we want to keep doing, shrinking your code's footprint and the boilerplate and the unnecessary ceremony as much as we can.
But the 2 way of declare namespace is still working. If I declare this way and the old way continue working.
The old way continues to work, but you can only do this if you do this one, then you can't use the other one in the same file, right? If you want to go, this one is for the whole file.
Okay.
We decided not to try to make them work together because we looked at GitHub and all the code in GitHub, and it is so rare that you'll want to do that. So we just said, hey, if one namespace doesn't work for you, just use the old syntax.
Okay, understand. I said that as just a sugar syntax for namespace. Just remove the brackets.
Right. I want to see, we're getting close to the 2-hour mark. I'm personally happy to stay longer, but I want to make sure that everybody gets sort of like, I got to show a lot of the things I brought. I showed them in a different order than I thought I would, but so I'm happy. I got through what I wanted. I'm
very happy to be talking.
So I'm happy to take a few more questions, and I also don't know. I mean, it's late in Brazil now. As you can see, there's evening sun here still. But I'm happy to hang out a little longer if there keeps being questions.
No problem.
And people can just drop off, if.
Yeah, in Brazil it's 11 p.m.
Mm-hmm.
Just a little later, not so later. You sometimes you are going to live in Codes in Real about midnight. 1 a.m., 2 a.m. It's not it's time. It's not. You're not worried about the time.
Good. Well, I'll stick around for a little longer for sure. It's only 7 p.m. here.
Yeah. We have some questions about. I don't know if.
Okay. What are the pros and cons in using RAII, resource acquisition is initialization, like Swift or Objective-C, instead of garbage collector? So the idea here really is that you're sort of, when you relinquish a resource, you are also destroying it. So it's sort of related to scope-based resource management, like you can do with some ceremony. You can do it in C# with the using statement. I think that those things work well sometimes. And the benefit is that when they work well, they're definitely more. Let me see if I don't have curtains in here. Let's see what I can do. There we go. When it, because it's more efficient. Like garbage collection has an overhead, and the overhead of garbage collection is sometimes non-trivial, right? So if you have a system that manages resources based on scope, then you can sort of have the compiler can predict when are you done with that value, and it's free to you don't have to track it at runtime. And there are some languages that have taken that to an extreme where you actually have lifetime built into the system. I'm thinking here of Rust, where the type system tracks lifetimes and sort of extends on that compile time tracking of when things should be cleaned up, so that it's not just scope based, but also you can transfer ownership to somebody else, and then it's their responsibility to clean up. And it tracks very carefully that you can't reference something after it's been cleaned up and so on. Essentially, if you don't have ownership of it, then you can't use it. I think that those things are good for low-level things where the performance really matters. It can be worth it to do even that kind of extreme lifetime tracking. It's just that garbage collection is so nice,
Yeah.
I never have to worry about this. I never have to worry about this. But then you do have to worry about it a little bit sometimes, after all, because sometimes if you don't null out a reference, you will keep an object alive for very long, and you can even create like out of memory situations and so on. Rarely, even in C#. But mostly, garbage collection is so nice, and I think that we might consider giving more tools for more resource management to be manual, or maybe even built into the type system, but it will certainly have to be something optional. We did actually have an internal collaboration with Microsoft Research a couple of years ago. We talked to them a lot. That's one of the nice things about being in a company that has a research organization. And one of the things they built was a very high quality implementation of manual resource allocation in C#, which has supposedly has similar performance properties to an RAII pattern, but we were actually unable to make it very much faster. We tried really hard and said, if we could get people to say when they are done using an object manually, can we optimize some things? And we could a little bit, but it wasn't worth it. So that was actually a surprise to us.
Yeah, understand. Another question: is there any downside to use global using?
No.
Shortly, just no.
Well, yeah, I mean, the downside is the using applies everywhere. You can't turn it off in a single place. Like we talked briefly about, should there be a way to say in this file, unusing the, something, should you be able to turn it off? But we decided, nah, it's not worth it. We can add that later if it turns out that becomes important. So global using is for the whole project, but you own the project, right? So you have the source code for all the project. And if you really don't mean for it to be global, then don't make it global. Just keep doing what you're doing today. So just don't. There are a few, I think it's very rare, but sometimes people have types of the same name in multiple namespaces that they want to import. That's already a problem today, right? Those two will clash. The only thing you can do now, and the only thing you can do in the future, is to disambiguate somehow. And you can use one of the existing disambiguating features, or you can declare one using outside and one using inside of a namespace, and then the one inside wins. There's these kinds of tricks. So we're not solving that problem. But that's not a downside to global using. It's just a problem it's not solving. So on the whole, it's not really, as long as you don't mind things being in another file, then it's fine.
Okay, Matt, thanks for your time to be with us tonight. Thanks again. C# has been incorporated some syntactic sugar later, like global using, and that's make the language learning curve increase. What's your opinion on this trade-off? Do you think that increase the learning curve?
Yes, this is a really good question, because I think this is a real problem. This is really the downside of us saying we want to keep evolving the language and making it better, is that at the same time, we can't take anything out. Like if we take a feature out, if you say, this is the new way, let's kill the old way, then we kill millions of lines of code, right? We break people. We don't want to break people. So we've been thinking about this a lot. Like, how can we make it so that when there are more than one way of doing things, that, you know, one is sort of the modern fancy way and one was the old way, how can we deal with that in the best possible way? And that's still work in progress. But one thing we're thinking about is to sort of to define what is modern C#, to sort of say, well, if you're doing this, this is the feature we recommend for this now, at this point in time. And maybe then that, you know, our documentation will reflect that. So it'll tell you what it means if you do the old thing, but if you're looking at prescriptive guidance, it will tell you to do the new thing. We can use that, and we are using that to update our templates so they will use newer features instead of older features. So you'll see a lot of that. That's not something we have done much, but you'll see a lot of that in C#10. And probably some of you will get angry because the templates will change. But they will, again, help recommend the new features instead of the old features. And it's not always the new, but the better features for a given thing. And then I think there are probably things we can do in tooling as well, and so on, to kind of help you modernize. There might be, you know, a set of fixers, code fixers that is like modernize your code. I noticed that you're using an old style using statement here, but you're just declaring a variable until the end of scope. Why don't you use a using declaration instead? It's much shorter and cleaner in your code, and, you know, that kind of thing, to help promote the ways of doing things that are better, that we've deliberately added to the old ways so that you can have a better experience. Let's help you have that better experience. And hopefully then the learning curve won't be so bad, because you're just learning one way of doing things, not all the ways. Of course, you still have to, if there's old code that you're maintaining and so on, you still have to understand what it does. So it doesn't fully solve the problem, but I think it will help if we get more intentional about what's good C#. What does good C# look like now?
Okay, there's a question. It's not an interrogation of C# language, but we will publish a new edition for the C# in programming language book.
I don't think so, because I don't think Addison Wesley want to do it anymore. That book was really the C# language spec, the specification for the language. And we're actually not, Microsoft is not making its own language specification anymore. Instead, what is happening, there used to be a somewhat separate effort to standardize C# through ECMA. And that died for a number of years, but then a number of us, both inside and outside of Microsoft, decided to revive it. And that is now an open source project that I can actually show you, the C# standard repo. This has the C# language specification in it, and it's open source, it takes contributions, and there's a standardization committee that I'm on, Bill Wagner from Microsoft, John Skeet from Google, several people from Facebook, including Eric Lippert. Like, it's all the people who have, all the top people who have been involved with C# at some point collaborate to make the C# spec good again. It's kind of been lagging for some years. It's not there yet. It's still a couple of versions behind, but it's now in Markdown. You can go to the standard and look at the table of contents here and go to any section in the specification. Here's something about types. Let's go and look at that. All in Markdown. And then we have a Word generator that we use to produce the actual PDF for the standard whenever we standardize a new version.
That's the book.
What's that?
That's the book. That's the Programming Engine book.
That is the book now. Exactly. And it's a work in progress, and everyone can contribute. So that's what happened to what used to be the book. Yeah. And I don't think there's ever going to be a print version of it again.
Yeah, I understand. I think you have the last question. I don't know if you... Okay. My last question. Do you think using TensorFlow.net C# is faster than using TensorFlow in Python, as Python is interpreted and C# is just in time? What do you think about this?
My guess is, if you're careful, you can probably make it almost just as fast in Python, to be honest. Because the main thing about TensorFlow, the main time sink about TensorFlow, for those who don't know, I mean, it's a framework for deep learning that is not built in Python. It's built in C++, I believe, and it does. You feed it a bunch of input, and it computes a model for AI kind of recognition stuff and neural network stuff. And I think that computation is probably generally the bulk of it. Maybe when you consume the models that come out of it, you can measure a difference where it's faster with C# than with Python. Not sure. I don't know. My guess is just that the efficiency of the surrounding code is dwarfed by the time that the actual engine spends. That's my guess, as a non-expert in that field.
I just have a doubt that I want to question. Do you think that interpreting language can be faster than compiling language? What do you
Absolutely.
think about it?
Absolutely, it can be faster. If it depends on how many times the same piece of code is getting executed. We have actually, when you look at C# expression trees, we have some experience with that. The C# expression tree API, there's an interpreter and there's a compiler for it. And it's really hard to get out of the sun here now.
Yeah. So your face.
My mic is in the headphones, so you should still hear me fine. I think that what we found was that it was only, unless you wanted to run an expression tree more than 80 times, it was more efficient to just interpret it. Now, an expression tree is a data structure. It's not a piece of text. So I think that interpreting a string every time and first converting it into a data structure and then interpreting that data structure, that probably is more expensive. But still, when you're interpreting, you're not doing anything that a compiler wouldn't also do. So all else equal, if you're just running it once, interpretation will be faster. And then there's some number, depending on various factors, where compilation will be faster. And if you look at some adaptive compilation techniques, Java has done a lot of that, actually. They've spearheaded a lot of adaptive just-in-time compilation techniques. They're all about speculating between how many times is it useful to execute something before we compile it, instead of interpret it? And then how many times is it useful to run the compiled thing that was compiled with a quick but dumb compiler before it's better to take more time compiling it but producing better code that runs faster? All those trade-offs. That's something that you can sort of tune and have a runtime that tries to figure out automatically.
Yeah, because we will have a history that Python is always slow because it's interpreted. It's slow because it's interpreted. Will be C# or Java is more faster than Python because it's compiled.
Yeah, it's generally true. Yeah, and certainly if you can compile things ahead of time, then the compile time does not factor into to the user's experience time, right? Then that's on the developer. So then, of course, that will be faster for the user.
Yeah. Usually it will be faster.
Usually. Yeah.
What about Node.js? It's some off-topic question about Node.js, about .NET Core or C#. Do you think that Node can be a rival for C# or ASP.NET Core? What do you think about Node environment ecosystem?
Well, it is a rival in the sense that there are scenarios that both are trying to be good at. Node is web native, right? So JavaScript is really like the language of the web, and using it for backend things minimizes an impedance mismatch in an ecosystem where you have maybe you have JSON-based data going back and forth over the wires and so on. You can lower the impedance mismatch a lot by staying within JavaScript and using a framework like Node. So and then if you don't like the untyped experience, you can slather some TypeScript on top, which yay Microsoft. And you can even get a decent tooling experience with that, and so on. So it definitely has some advantages there. Of course, C# then has, again, it's compiled rather than interpreted. It has a much stronger type system, and it's much more expressive in many ways. And it is a language with much broader applicability. It applies to many more domains, and so you can better share things across domains, maybe, as opposed to just across a narrow stack from like backend to web. So I think they both have their benefits. One thing that I think is important is that WebAssembly is becoming more and more real and more realistic, and we're definitely taking advantage of that. So the JavaScript is king kind of situation on the web, where you couldn't avoid JavaScript, that is slowly but surely being dismantled. That monopoly is going away, and eventually, you won't think much of running C# rather than JavaScript in the web, and so that's a long-term evolution that we're strongly backing, and with Blazor and things that we're really pushing on that, because it seems wrong that just one language, that you only have one language to choose from whenever you're doing web stuff natively.
Do you think that Blazor can be built a great system, big system with Blazor? What do you think about Blazor in the future? What do you see about the Blazor for web development?
I mean, it's work in progress, but it's. I think it has a lot of potential. I think so I'm not working on it. So, but I think that we're generally thinking about it the right way, where it's not some isolated kind of technology for one specific thing, but we're trying to remove the barriers between the front end and the back end, and between compiled to WebAssembly versus running classic.net, and trying to make it not something special, but just a way of using .NET. One of the many ways that you can use .NET that integrates with all the others, I think is the right approach. And now we just need to double down on, making it more efficient and capable of running bigger and bigger things. We need to get better at ahead of time compilation technology. Traditionally, we've done IL, just-in-time compilation, for almost all .NET execution. We've had some things like Xamarin for iOS, for instance, have been ahead of time compiled for a long time. And that's something that we continue to want to get better at, because that's also important for Blazor's future, rather. And I hope that we'll get to a point where ahead of time compilation versus just-in-time compilation is sort of like not a big deal.
Oh, okay.
Well, yeah.
Well, you have 2 hours alive, 2 hours 10 of alive. I think that's the last question. What? It's I just saved it for the last question. I confess. I think it's a great question, not about the language or about .NET, but about the feeling. What do you think? What was the main difference you felt in the public acceptance of C# after the movement of Microsoft to go into open source? What are you feeling that the community accepts C#, Microsoft technology when Microsoft is moving to open source?
I think that a lot of suspicion gradually disappeared, right? People were concerned. Back when, you remember, C#.NET was all about Windows, all about Microsoft technology, it was a tool that people were offered if they bought the whole package of Microsoft technology, and otherwise, unless you used Mono and one of those like rogue technologies. But I think it's taken a little while to convince people that we're really serious about not just being open source, but also being cross-platform, cross-IDE, and cross-platform, both in terms of operating systems at the high level and in terms of underlying processor architectures and so on. That we really honestly want to make this technology available everywhere. And I think one thing that actually has helped is I think people know that we're not just doing this out of the goodness of our hearts. It's not just because, oh, we love developers and we want the best for them, and that's Microsoft's mission in the world. No, people are suspicious of that kind of thing. Like, what's in it for Microsoft, they say, right? And in this case, it's clear what's in it for us. Like we have a cloud offering in the market, as among other things, but we have some platforms in the market, but notably Azure, that we want as many people to have as easy a time as possible using, right? So it's clear what's in it for us. It's to our benefit that these tools are as accessible and as useful as possible.
If I tell you that people nowadays think that Azure only run Microsoft stack, especially in Brazil, sometimes I have some events that people ask, just Azure for Microsoft, just only run Microsoft stack. It's not true. Azure run anything you want to run, any technology.
Right, and it's not true, but it used to be true, right? And started there. And so I can understand why it takes a while for people to also, it's one thing to say, oh, we run Java, we run these other things, but do we really? Is it really like something you want to bet your business on? It's taken us a few years to prove that, yes, we really, really mean that we want to support these things. To the degree that we, as we talked about earlier, we have a team implementing Java, right? We have our own team implementing Java. That's how serious we are about running people's Java jobs on the Microsoft stack. On Azure. So we have probably way more jobs in Linux than in Windows now in Azure and so on. So, but it takes time before people see that we're serious about it. And I think that's been a gradual process, but I think it's really coming around. And I mean, there's a reason why Azure is the second biggest cloud provider. It's that people are starting to trust that, and they have good reason to.
Yeah. I think the barrier is going down in the future, and I think the people think because the past of the Microsoft, and because Microsoft changed the mindset of the old Microsoft into a new Microsoft, and it's more open about a lot of technology, not just C# or .NET Core, but it's more open about any technology, and the people don't see or can't see this. It's I think it's more, how can I say, it's more close your eyes and not see what Microsoft is going to do about the technology, about the cloud, about Java, about Node, about Python, about Ruby, and includes this technology on stack on Azure. I think that this barrier is going down in the
I think so, but I think it's, I mean, I can understand where people are coming from, right? People generally are cautious about separating what's real and what's bullshit, and it takes time to prove that you are for real, and I understand why people are hesitant, and they take their time looking at our actions and not just our words, and seeing that things actually generally play out in a way that they like. And we have, I think we've been mostly successful now for some time doing that, proving that we are serious about open source development, that we are serious about supporting a broad set of different types of workloads and so on. And so people are starting to believe in it.
To rely and believe in Microsoft.
Yeah. But it's fine that people are skeptical. I don't have a problem with that. I would be too. So.
Yeah. We have any question? I think no. I think it's over of question. Yeah, I have 2 hours and 20 minutes of live. I think it's okay. It's great. I'm very happy to talking with you, Mads. It's a great honor to talk with you. It's my feeling.
I want to say thank you, everyone. Those were great questions. It's amazing how much of a conversation you can still have, even though questions are like in writing and so on. But this has been great. Thank you for great questions and taking us to exciting places in the discussion. It's been a pleasure talking to all of you.
Thanks very much, Matt. Thanks very much, people. Pessoal, vamos terminar aqui por hoje. Já são praticamente 11h30. Muito obrigado a todos que estão aqui. Cara, muito obrigado a vocês que estão aqui. Thank you very much, Matt, to be here on our channel. It's a great honor to receive you on our channel. Thank you very much. And good night. Pessoal, muito boa noite. Muito obrigado por vocês estarem aí. E, cara, se vemos aí no próximo Talk Coders que a gente vai fazer agora, falando um pouquinho sobre React. Cara, obrigado a todos aí. Obrigado, Mads. Thank you very much, Mads.
Obrigado.
Good night to everyone.